This is for you, Noah. I already pressed play. All right, here we go. So what is side A, or side length that we're given from figure A? 5. Are we given a side length from figure B? No. So we're going to put X. Are we given the perimeter from figure A? Yes, 60. And the perimeter from figure B is? 84. All right, when we have one fraction set equal to another, we do cross multiply. We're going to need a calculator. So we're going to do x times 60 is 60x, and then, actually, I think this is 420. 5 times 84 is 420. Divide by 60, and x equals 7. 7 inches, technically. For the area formula, it is very, very similar. You do side, I can't spell. I don't even, side A over side B squared equals the area of A over the area of B. So what side length, or did they give us a side length for side A? They did. They gave, what is it, 88 feet? Did they give us a side length for figure B? I'm the worst. No, it's X. All right, do we have area for figure A? 4,928. And then the area for figure B? 77. Perfect. All right, now we're going to square. Remember when you're squaring a fraction, you square the top and you square the bottom. So what is 88 times 88? And then what is x times x? X squared equals... Good. Now we multiply. I'm going to run out of room. It's just going to happen. So we get 4,900, what is it, 72? No, 28. 28x squared equals, what is 7,744 times 77?
596,280.
Did I get it right?
Yes.
Perfect. Next thing you need to do is divide both sides by 4,928. Divide. Hold on. Tita, are you going to like this on a test?
Yes.
Take square root. What does x equal? 11. So make sure you take note of both formulas. You are going to use them both in class, and one of each is on the quiz. So out of 11 questions, 2 of them are going to look like this. I think it'll have the picture, I want to say. Questions about these 2? Your quiz is on Friday. Perfect. All right, so we're going to talk about 8.2. It is over similar triangles. The entire chapter is over similar triangles. Basically, what I want you to write down in the top, it says similar figures. They have congruent angles and proportional sides. They have congruent angles and proportional sides. If you know this sentence, then the next 3 lessons are going to be very redundant because this is all that we're proving. Today we're going to be proving that if they have congruent angles, then they're similar figures. And then we're going to be or proving if they have proportional sides, then they are similar figures. So if you know these 2 facts, these lessons will be pretty easy. Okay, so a figure that is similar, or 2 figures that are similar, they're the same shape but not the same size. If you look, I have these 2 I'm just so done with life, guys. We have 8 weeks of school left. I'm going to die. They're 2 stars, right? You would say that they're similar. They're the same shape, just 2 different sizes. Okay? So similar figures. So basically what you're going to learn is that if 2 of the angles of one triangle are congruent to 2 angles of a second triangle, then the 2 triangles are similar. Because remember, to make it similar, the angles have to be congruent and the sides have to be proportional. Well, in this case, if 2 of the angles are congruent, what do we know about the third angles? They're also congruent, just by default. Okay, so in this section, we're going to be deciding whether triangles are similar. Just going to let these things pop up. Oof. back. Determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. So let's decide if we have, it looks like we don't have two pairs of congruent angles. But what we do need to do first is check what this angle of E will be. What do we know about the three angles in a triangle? They add up to 180. So we can figure out what 90 and 26 make, which is 116, yeah? These two already added together, 90 and 26, make 116. Subtracted from 180 is 64. So we have two congruent angles in the first triangle and two congruent angles in the second triangle. So are these two going to be similar?
Yes.
Yes, they are. So it says, yes, they're similar, and then it says, write a similarity statement. So this is where we name one triangle, and we call it similar to a second triangle. So pick an angle in the first triangle. C. What does C correspond with in the second triangle? Okay. All right, pick another angle in the triangle. D corresponds with G. And then the last would be E and H. So this would be your final answer. Explain your reasoning. It'd be because the angles are congruent. The angles are congruent. Then we flip. We do the 2 at the top, and then we move on to 8.3. So this is show that the two triangles are similar. You will have one or two of these on the quiz. So this is pretty much the only thing you'll have from 8.2. You won't have anything from 8.3 on the quiz. But it's not asking if they are similar. It's telling us that they're similar. We just have to decide why that they are similar. And according to this section, we learned angle-angle similarity. So basically, if two angles are congruent, that means the triangles are going to be similar. So we need to list which angles are going to be congruent. Sometimes it helps if you separate the triangles. If you look, this top triangle is small, and then there's an outer triangle. So if you want to do that, you can. But which angles are congruent in the first place? 52 and 52. So we're going to name them. Since you can't say angle B, there's two angles at angle B, you'll have to name it with 3 letters. So what 3 letters would we use to name this angle? EBA or ABE. We list that it is congruent to a second angle, which is this one. You could say either DCB or DCA. So, DCB or DCA, either one. Then we would need to name a second angle. What other angle do they have congruent? Angle A. So we could say angle A is congruent to angle A. You could use 3 letters if you want to, but there's only one angle at angle A, whereas angle B had 2 pieces. You good with that? All right, so that would be your showing that they're, oh my gosh, I did not mean to do that. There we go. This would be how you show that they are similar, the 2 angles. Letter B, there's a couple things that you can do. It doesn't look like anything is congruent, but there are. What angles are congruent that aren't marked? Yeah, at angle V, what do we call these angles? Vertical, yeah. So we do have to name these with 3 letters because there are 2 angles at V. So we would say angle, we could say SVR. Is congruent to, how would we name this angle over here?
TVU.
TVU. All right, and then there's a second set that you could name. There's actually all 3 of them you could name. What do these little triangles mean in this picture? They're parallel. So what does it mean when you have two parallel lines and a line that cuts through them. What do we call that? A transversal. So if you remember, because of a transversal, these two would be alternate interior angles. So this angle and this angle. And alternate interior angles are congruent. So we could name both of these. There's only one angle at R and one angle at T. So we could say angle R is congruent to angle T. Is there another set of alternate interior? There is. Highlighted them in blue, would be these two angles. And again, there's only one angle at S and one angle at U, so we could say angle S is congruent to angle U. You technically only had to list two of these, but just in case you look back at your notes, any combination of two of these would have been fine. All right, we're going to go to 8.3. 8.3 is called proving by side, 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 or side angle side. Basically, if corresponding side lengths of two triangles are proportional, then the triangles are similar. This is still not new information. They just put it into a different lesson. So basically, if the appropriate side lengths are proportional, then the triangles will be similar. So in this section, you're going to decide which triangles are similar to which triangles. So we're going to decide if DEF or GHJ is similar to ABC. So basically, we're trying to figure out which one of these is similar to ABC. So all we're going to do, I know on your paper it's not color-coded. On your test, it won't be either, but you can also still look at the letters. So like AB should correspond with GH or DE. Does that make sense? So the first two, BC should correspond with HJ or EF. Do you see what I'm saying? So you can still just look at the letters if it's in black and white. But anyways, we're going to start with DEF. We're going to see if they have the same scale factor between each side. So a scale factor is the number that you multiply from one side to get to another. So we'll start with the red since I'm on the color red. We'll just find the scale factor from ABC to DEF because it doesn't matter. So 8 times the scale factor gives us a side of 6. So 8x equals 6. Divide by 8. So what is the scale factor? 3/4. So basically all of the other sides need to have the same scale factor of 3/4. We'll do the same thing with 12. What does 12 correspond with? 9. So 12 times the scale factor gives us 9. Divide by 12. What's 9 over 12 reduced to? 3/4. It's looking good so far. We have the last set of sides. 16 times the scale factor gives us 12. Divide by 16. What is 12 over 16 reduced to? 3/4. So, are these two triangles similar? So then your answer would be, because it's asking which, it's either DEF or GHJ that is similar, so we're going to say triangle DEF is similar to triangle ABC. You could also kind of tell because HG is 8. What does this 8 correspond with on triangle ABC? So it's in red. What's the red side on ABC? 8. What would the scale factor be if I went from 8 to 8? 1. But the red is 10 and 12. So is the scale factor 1? No. So this would have, you could have looked at it and said no. All right, so there's that. There's deciding if in general, it'll take 2 seconds. Okay. We're going to decide in general if these triangles are similar to the triangle that's given to us. So I know on your paper it looks a little different, but these are two separate problems. We're going to compare this triangle to ABC, and then you would compare this triangle to ABC. So two separate problems. So determine if triangle RST is similar to triangle ABC. So what side, we're just going to pick one, what side would correspond with ST? Yeah, CB, which is 5, yeah. So to find the scale factor, we would do 7 times a number. Gives us 5. 7 times scale factor is 5. Divide by 7. I want to say this one, we're going to find it in decimals. Just because, you'll see. What is 5 over 7 in decimals? 0.71. So that's a scale factor for the blue sides we did. If we wanted to do RT, what does RT correspond with? Yeah, CA. So 4 times something will give us 2.5. Divide by 4. What is the scale factor? It's point something. 6 what? 6, 3. All right, so already, can we tell if these are the same scale factor? They are not. So this would be not similar. All right, we're going to skip the second one because you guys don't really, I don't think, need the second example. We're going to flip to the back. We have 2 more to do together. This is also on the scavenger hunt today. So it says find the value of x that makes ABC similar to triangle DEF. So we're going to find the value of x. You're going to set this up the same way you've been setting it up. Which x do we want to solve for? I always pick the easiest one. So yeah, let's find x minus 1, which is BC. What does BC correspond with in the second triangle? EF. So we're going to do BC over EF, which is x minus 1 over, what is it, 18. All right, we need to set it equal to a second fraction. Since we have BC in the top of our first fraction, it's from the first triangle, we have to pick from the first triangle again. So I would pick one of the easier sides.
AB.
Yeah, I'd pick AB because it corresponds with DE. So we're going to have AB, AB, which corresponds with DE. What is the length of AB? And then DE is 12. All right, so you cross multiply like normal. What is 8 times 4? 72. However, when you go the other direction, you have to make sure that you are multiplying 12 times the entire side. So it should look like this, because you're going to end up distributing it. If you just do 12x minus 1, you're not multiplying it times the entire side. So we'll distribute like normal. So we're going to have 12x minus 12. Add 12. What is 72 plus 12? 84. So we're going to have 84 equals 12x. Divide by 12, and x equals 7. How do we feel about this problem? Are we okay to not do another one? Okay. All right, so